Okay, but today I want to talk about this part called semiconductor diode. Okay, and as I was preparing for this lesson, I realized that there is a huge chunk, there is a huge chunk of explanation that is missing from your textbooks. Okay, and I feel that if I don't address this part, if I don't introduce to you, okay, the basics of a semiconductor diode, I feel that when we go into the activity one, which is like right at the first page of your module, right, I feel that you will be a little bit lost, like what's happening over there. Okay, so this next few slides that you're going to see is not going to appear in your module. Okay, you don't really have to copy this down because actually you don't, how do I say, dia bukan benda yang akan diuji masa peperiksaan lah. Okay, but in order for you to understand how a semiconductor diode works, you have to know what I'm talking about. Okay, you have to know this introduction part now. Okay, so maybe for the next 10 minutes, just sit back and relax, listen to the sound of my wonderful voice, okay, and try to catch on what the semiconductor diode actually is. Okay, so a semiconductor diode, okay, consists of two very important words which is semiconductor and diode. Duh. Okay, we first need to understand what is a semiconductor, and secondly, we need to know what is a diode. What does the semiconductor have to do, okay, with the diode? Okay, so when we look at our technology today, we find that things are getting smaller and smaller. Okay, in the past, the radio was like huge machine, okay, full of electronic components. Okay, and the newer model, the one with the big back that we talked about, the cathode ray tube, okay, also is big but it's definitely smaller than the older one. And now, of course, well, who listens to radio nowadays, right? Okay, fine, but our TV is getting even smaller and smaller. Okay, so we find that electronics has progressed to such a stage where we are able to make things that are smaller but can hold a lot more stuff. Okay, do you know when I first started using a pen drive okay, I don't know who uses pen drive nowadays okay, so pen drive is like this huge, okay, this is not a pen, this is not a new pen drive but pen drive is huge, okay, and then they can only hold 512 megabytes. That's 0.5 gigs worth of this one. But now we can have pen drives that are super tiny, not even called pen drives anymore. We call them memory cards. Okay, they can hold up to terabytes of information. Okay, and that's how the technology of electronics has progressed. We are making better and better things, but in a smaller and smaller scale. Have you ever seen the computer when it first appeared? Okay, the computer is a huge machine that looks like a cabinet, macam cabinet, macam almari pakaian. Okay, and look at the laptop that you are using now. It is super tiny and super small. And yet when you carry it, you're like, oh, so berat lah saya punya laptop gitu. Cuba bayangkan, okay, in the old days computer, okay, nobody can complain about the computer because it's memang sangat berat. And so we find that even in so the electronic components okay, so there's a diode over here, in the diode, very very huge components. You look at the television today, okay, the diodes are much smaller, okay, and okay, so this is the inside the TV, okay, this is the electron gun okay, the cathode ray tube is this, okay, but there's all these other components here, okay, which one of it we are going to talk about today, and then in the next subtopic is another one called the transistor. So the diode and the transistor have actually changed the world of electricity and electronics, so much so that we are able, as I said just now, to hold more information or to send more information, okay, using a small amount of space. Okay, that's how technology has progressed until today. Okay, so the first thing that we need to talk about is materials. Materials can be classified as insulators, tidak boleh mengalirkan tenaga elektrik, conductors, which are pengalir, okay, and then semiconductor. Sorry, insulator is what in Malay? Penebat. Okay, and then semiconductors. Semiconductors are conductors which are conductors which are in between conductors and insulators. So dia punya pengaliran arus tidaklah sebaik konduktor, but tidaklah seteruk penebat. Okay, so dia punya kekonduksian elektrik lah. The electrical conductivity of a semiconductor is in between. Okay, so normally when you put a conductor, okay, into this one, you are going to expect current flow. Okay, when a potential difference is applied across the conductor, the electrons will move in the same direction, okay, towards the positive terminal. So if this is the positive terminal over here, the electrons are going to move this way. But we know that current flow, okay, I'm going to change color for this. So current flow is this way, okay, from positive to negative. Okay, but electrons flow the other way around, okay, to produce the current. Now, a semiconductor works along the same process, cuma ada sedikit, there is a little bit of adjustment that needs to be made lah. So some examples of pure semiconductor elements are these two, germanium and silicon. Again, saya mau cepat-cepat ini sebab this is just an introduction lah. Ini bukan perkara yang akan diuji dalam mana-mana peperiksaan, because sebenarnya it's not even in your textbook. You open your textbook, you won't see any of this. But I feel that I need to explain this because otherwise when we come to what the diode actually is, you'll be like, huh? Kenapa tiba-tiba ada benda ni? Okay, so please bear with me. So a semiconductor is a material where the resistance and the electrical conductivity is between conductors and insulators. And generally we find unsur yang menjadi semiconductor yang baik are usually in group 4, okay, in the periodic table, which is here. Okay, sorry, group 14 lah, fine, kumpulan 14 or group 4 lah, depending on whether you use. So group 4 is over here. So these are all very good semiconductors, okay, not as good as conductors, okay, which is like here, okay, metals, okay, but you know, they're definitely better than the non-metals. Okay, so for example, in a semiconductor, okay, there are these things called free electrons. Okay, free electrons in semiconductors is less than the conductor. Hence, semiconductors have a high resistance than conductors. So we are going to see this word free electron in a little bit lah. Okay. So in silicon and germanium, because dia adalah kumpulan 4, okay, dia kumpulan 14 or group 4 or 14, depending on how it is. Okay, so we know that because they're in group 4, the valence electrons are 4 outside. Okay, germanium also will have the same thing lah. Dia ada 4 electron valence di petala paling luar. So because of that, it is able to form a covalent bond, okay, dengan, you know, antara satu sama lain with no free electrons. Okay, sebab kalau saya ada, oh no, this is chemistry, yucks. Okay, sorry. Okay, and then you have another Si over here, right? Okay, I know there's 4 electron valence, but because there's a covalent bond, okay, so all the electrons, they share the electrons and you will form a perfect octet. Okay, form a perfect octet means tiada elektron yang bebas. Okay, this is in chemistry. But, okay, and this is at low temperature. Okay, there are no, pada tahap normal lah. But when we provide a little bit of temperature, okay, when we provide a little bit of temperature, what is going to happen is some of the electrons are going to break away and become free electrons. Okay, when we give it a little bit of temperature, kita beri sedikit tenaga elektrik, the electrons are going to get enough energy and start to break away from one another. Okay, and so because of that, the resistance of the semiconductor at the high temperature is low. When we make the high temperature dengan membekalkan arus lah. Okay, we provide some electrical energy to the silicon so that the free electrons can flow. So because of that, the electrons are going to leave all these vacancies. Okay, akan ada ini tempat-tempat kosong ini. Sebab elektron itu sudah pergi bergerak entah ke mana lah. So tempat di mana elektron itu last time was there is now empty. Okay, and we call this a hole. Wow. Okay, yeah, because it's empty, right? Okay, so it's a hole. Okay, just like the hole in my heart when you're not there. Oh, gosh, so lame. Okay, so it's like that lah. When the electrons are gone, they leave a hole. Okay, and we assume, and it is known that the hole is positively charged because there are electrons di sana. Okay, when the electrons are gone, okay, left the hole, so it is positively charged. So the first and most important thing we need to understand is that in a semiconductor, there are two types of charge carriers. There are electrons, okay, and there are holes. Holes are places where the electrons have left empty, okay, and holes boleh diisi, the holes can be filled by other electrons. So let's say if I'm an electron at the place, then if I leave, another electron can come and fill in that hole, okay, to neutralize the situation. Okay, so what happens if a potential difference is applied across a semiconductor? Okay, so this is what actually happens. The free electrons will be attracted to the positive terminal. And so the valence electrons in the neighboring atoms are then pushed to occupy these holes. But in the process, they will create other holes which will be later occupied by other electrons. So the movement of electrons is in the opposite direction as the movement of holes. The movement of electrons and holes contribute to the flow of the current. So take a look at this. The electrons will be free, so the other electrons have to fill in the holes. Okay, because these electrons are nothing better to do, say they membebaskan diri. Okay, so they will fill in the hole. So it looks as if the electrons are moving. Okay, so yeah, so it looks as if the electrons are moving. So the movement of electrons is one way, and the movement of holes, it looks like the holes is moving, but actually the holes is not moving. It's just being replaced by other electrons. So itu adalah benda yang menyebabkan that will contribute to the flow of the current. Okay, so the electrons move in one direction, the holes move in the opposite direction. Okay, and this contributes to the flow of the current. Since the number of electrons and holes in a pure semiconductor is generally low, so the ability to conduct electricity is also low. That's why it's called a semiconductor. So there's not enough electrons, okay, in order to there's not enough free electrons to flow so that the conductivity is better. Okay, maybe one only is free. Okay, you would imagine that if there are 4 valence electrons, all 4 will be free to move around, right? No, they're not, because they're still stuck by the covalent bond. Okay, so yeah, this is Marcus trying to teach you all chemistry, which is obviously not working. Okay, I think you covered this in chemistry also somehow, but I can't really remember. Okay, so let me skip this one. Okay, let's not talk about doping now, but basically there are 2 types of semiconductors that can be obtained. Okay, and the reason why, again, I want to mention this now, because when we come to the actual module, okay, these words are going to come up. There are 2 types of semiconductors, which is the N-type semiconductor and the P-type semiconductor. Okay, ada 2 jenis semiconductor lah, N-type and P-type. Okay, so the N-type semiconductor is where there is an abundance of electrons. Ada lebih banyak elektron daripada holes is lohong in Malay. Okay, there are more electrons than holes, so we call it an N-type semiconductor. A P-type semiconductor is where there are more holes than electrons. Okay, so the 2 big differences is there. N-type is more electrons than holes. P-type is more holes than electrons. Okay, never make the mistake of saying that N-type is only electrons. Jangan juga, it's not that. N-type just means there are more electrons than holes. In a normal type semiconductor, okay, no N-type, P-type, the number of holes and electrons is always the same. Okay, kalau dia adalah semiconductor biasa. Kalau ada 4 lubang, ada 4 elektron. Number is the same. But in the N-type semiconductor, you have 5 electrons and 4 holes. Okay, so this is an N-type semiconductor. So ada lebih 1 electron. P-type semiconductor will be, maybe you have 5 holes and 4 electrons. Okay, so there is 1 extra hole, which makes the semiconductor a P-type semiconductor. Okay, so again, the reason why I wanted to point this out is one of the biggest mistakes that students always make is they assume that N-type semiconductor is only electrons. Not true. Okay, both semiconductors got hole, got electron. It's just that satu more electrons, the other one is more holes. Okay, so if for the past 20 minutes Okay, you've been like, apa ni, sir, why are you talking so fast? Okay, I just want you to understand this lah, that there are two types of semiconductors, which is the N type and the P type. Okay, and how you differentiate is the number, which one has more, not only electrons and only holes. No, okay, they are the lebih electron, N type. They are the lebih lohong, P type. Okay, because then now we can talk about the function of the semiconductor, okay, which is in your module now lah. Okay, so thank you for bearing with me for the past half an hour, or for the past 20 minutes. Okay, so let's begin. So the transmission of electrical power to consumers through a network is in the form of alternating current. Okay, when current comes to us, okay, from a generator, and then the transformer, and then the transformer, then they step down, comes to our house, it still comes to us as AC. Okay, but how is the alternating current, okay, changed to direct current? Because most of our electrical devices can only function with direct current. Imagine if your lamp, or imagine if your TV functions with alternating current. Okay, you're going to get cluck, 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 cluck. You know, it's going to be blinking a lot until your eyes will become very painful. So there has to be something that converts alternating current to direct current. And this is where diode come into play. Okay, this is where semiconductor diodes are important. So let's discuss the function of a semiconductor diode. So this is a diode. Okay, this is the symbol of a diode. Okay, you will find that there is a triangle which represents the anode leg, and there is a stick of penghalang here, okay, which is a representative of the cathode, okay, which is a negative terminal. Okay, and so we find that if we connect a diode in a forward bias position, for example, this, okay, look at this. Okay, so let's make a few notes over here, people. Number one, I want you to notice that the diode here is positive and here is negative. Okay, so the forward bias is positive terminal of batteries, okay, is connected to the anode. Okay, so we call this situation forward bias. Okay, dalam bahasa Melayu is pincang ke depan. When the positive terminal of the battery over here is connected to the anode of the diode, we call this forward bias. And we notice that when it is forward bias, okay, the bulb will light up. Okay, according to this gambar raja lah. Unfortunately, we're not in school, so I can't really show you this. Okay, now look at the reverse bias. Look at which terminal is being connected to the anode of the diode. It is the negative terminal. So again, write down there in your module, reverse bias is negative terminal of the battery is connected to the anode. Okay, sorry, I'm too lazy to write the whole thing now. Okay, I don't have enough space. Okay, so this is a very important thing. When the diode is connected forward bias, okay, bila dia disambung pincang ke depan, the bulb will light up. Okay, now if the bulb lights up, it means that current is flowing. Yalah, obviously lah kan, if the light is menyala, maksudnya arus mengalir lah. But if the bulb doesn't light up, okay, it means that the current isn't flowing. Something is wrong. Okay, the current isn't flowing. Okay, and it has to do with the way we arrange our diode. Is it arranged forward bias or is it arranged reverse bias? Okay, so which terminal is connected to the anode tells you whether it is forward bias or reverse bias. So number one, what is the function of the diode in this activity? The function in the diode is to only allow current to flow in one direction only. This is generally the function of the diode, not just in this activity lah, but in general, diode only allows current to flow in one direction only. Okay. So number two, state the condition when a diode allows the current to pass. This is the only condition where current can pass through the diode, which is forward bias. Okay, Now, if the dry cell is changed to an alternating current power supply, what will happen to the bulb? Anybody want to guess? If let's say I change these batteries, I change it to alternating current power supply. Okay, what's going to happen to this bulb? Anybody want to guess?
Berkelip-kelip.
Okay, why would it berkelip-kelip?
Sekejap positif, sekejap negatif di anode.
Wilson is on the right track. He says that dia sekejap dia akan menyala, dia akan berkelip-kelip lah, because sekejap positif, sekejap negatif yang akan tersambung kepada this one. Because alternating current is sini positif, sini negatif, and then the next minute sini negatif, sini positif. So that's true. But talk about the condition. It is actually sekejap forward bias, sekejap reverse bias. Sorry. So the forward bias and the reverse bias will alternate. Okay, because of the alternating current. So the bulb will light up and light off alternatively. Or you can say the bulb will start to blink lah. Okay, so whenever we talk about semiconductor diode, people, okay, try to kasih selitkan the perkataan forward bias, reverse bias. Because that explains, when you say forward bias, reverse bias, everybody understands already. Okay, daripada kau cuba menjelaskan, okay, because the positive terminal of the battery is connected to the anode. It's very long. Okay, forward bias, everybody understands. Okay, the word forward bias. Okay, so we try to use those words. Okay, now we talk about this. This is why I was talking about the P and the N semiconductor just now. So a diode is actually formed when you join a P-type semiconductor and an N-type semiconductor together. Okay, to form a P-N junction over here. Okay, so this is a P-N junction. Okay, so this is actually a diode, and as we said just now, a diode is a device that allows the current to flow in one direction only. Sorry, I need to check something. All right, that's why I mentioned just now. Now remember, P-type semiconductor means more holes. Okay, more holes, tapi bukan bermaksud no electrons. Okay, it's just more holes than electrons. N-type semiconductor is more electrons. Ada holes, tapi lebih banyak elektron. Okay, itu yang sangat penting. Now, the next few slides that you're going to see is not in your module, but it is a very important explanation for the table that you're going to see later. Okay, I believe that this is the thing that is next in your module. Okay, but the explanation to this okay, is explained by this lah. Okay, so listen carefully. Okay, first thing is we need to talk about the PN junction. Okay, bila kita gabungkan satu semiconductor P dan satu semiconductor N, okay, we are only interested in the extra holes and the extra electrons. Okay, so a PN junction is formed when the N-type and P-type semiconductors are joined together. So this is the junction. Okay, dalam bahasa Melayu, junction is simpang. Now, the boundary between the P-type, okay, and the N-type is called the junction. Now, at the PN junction, the electrons from the N side yang bebas ini, okay, akan bergerak ke sebelah P and combine with the holes. Okay, and similarly, the holes from the P side will move to the N side. Actually, it's not moving. What is happening? Dia akan meninggalkan lubang di sini. Remember in the beginning part, I said that the holes actually not moving one. Holes is just the tempat di mana elektron boleh masuk. So bila elektron itu keluar, sepertinya you have left a hole in my heart. So the holes is just there. Okay, so when we say this, holes from the P side similarly move to the N side. Sebenarnya they're not moving, they just tertinggal di sana. But when we explain it, we say move because it makes a little bit more sense lah. Okay, where they will recombine with the electrons. Okay, so the N type is positively charged, okay, and the P type is negatively charged for a while over here. Okay, so this is what's happening. Now, when that happens, okay, bila electron melompat ke sebelah sini dan meninggalkan lubang di sini, okay, there is going to be the region around the junction is left with neither holes nor free electrons sebab the electrons sudah melompat ke sini dan bergabung dengan lohong. Okay, and then the lohong yang ditinggalkan di sini, okay, bergabung dengan elektron, and so what we will have is we will have a depletion layer. Okay, in Malay it's called lapisan susutan. Susutan. Okay, and okay, so the lapisan susutan over here, okay, stops the electrons from going over. Okay, the electron cannot go over already sebab tiada ruang, tiada tempat untuk mereka pergi. Okay, and the holes from here pun tidak boleh melompat ke sebelah sini because of this depletion layer. Okay, it has already been neutralized lah. When the holes and the electrons have been combined, okay, they will leave a depletion layer which is neutral. Okay, so the function of this depletion layer is to stop any further movement. Okay, is to repel any further movement by the charges in this layer. Okay, so the layer there is very important because kalau the electrons cannot move, okay, then current cannot flow. Okay, and that's good lah because we don't want them to just keep, saling menarik antara satu sama lain walaupun tiada current mengalir. It's not good. Okay? Sorry let me tell you the reality lah. The reality is the explanation is actually much more complicated than this lah. Okay? But you're not really required to know the explanation. You just have to know what is the depletion layer. Okay, the depletion layer is a layer that stops the charges from moving across until you give them some more energy to move across. Okay, but the problem is I cannot talk about the depletion layer tanpa menjelaskan kenapa ada depletion layer itu. Okay, the depletion layer happens where the electrons come to this side and then the holes go over to this side dan meninggalkan ruang kosong semua di sini. Okay, it's just like, okay, tiada tempat sudah. Okay, so, sorry. Okay, so now we come to the junction voltage. So if there's a junction, there must be junction voltage. So at the junction, and I hope this explanation makes a little bit more sense. At the junction, okay, the N-type region forms positive ions because the holes, because the electrons have already hopped over here. Okay, untuk mengisi ruang-ruang positif di sini. So dia kasih tinggal the holes over here lah. Okay, and the P-type region forms negative ions here because the electrons have already already jumped over here. Okay, so because of that, this results in a potential difference which is known as the junction voltage. Okay, a negative charge on the p-type side will repel any other electrons that might cross the junction. Okay, are you guys like, oh no, why are we studying this in the afternoon? Okay, let me. Yeah, I know this is not a very good thing to study at 3 o'clock in the afternoon. Okay, when we put the P and the N together, okay, originally you're gonna have all these positive. Sorry, nobody is responding lah. So I'm just assuming that nobody understands what I'm talking about lah. Negative. So all these are holes. Okay, all these positive parts are holes. All these are electrons. Remember, electrons are the only ones that are moving, and when they move, they leave holes behind. Okay, so when the electrons jump over here, okay, they're going to fill up all these holes. Tetapi oleh sebab mereka melompat, they are going to form the holes over here. Okay, and because of that, kewujudan, the existence of the holes over here, okay, will stop these holes from going across, and the existence of the electrons over here will stop these electrons from going over here. So because of that, okay, the electrons over here tidak boleh bergerak ke sini dan the holes over there, okay, tidak boleh diisi. Okay, because ada macam penghalang sudah di sini. Okay, the first layer has already formed the penghalang. And that's why we call this the depletion voltage. The depletion region. Okay, or the junction voltage lah. Okay, the depletion region is also known as, the potential difference across the depletion region is also known as the junction voltage. Okay, saya conteng ini because this is a very frustrating subtopic to learn lah. Okay, it's not confusing, but it's just okay, it's a lot of words lah. Okay, so at the junction, the positive ions form at the n-type region because they lose the electrons. Then the positive ions here repel the holes. Okay, they cannot join. At the junction, the negative ion is here because the electrons jump over. Mereka tertarik kepada, lubang lah, obviously. Okay, but because of that, okay, the negative ions here will repel the electrons from crossing over. Okay, so this first layer is very important, which is why we call this the depletion layer. So the function of the junction voltage is to prevent the charge carriers from drifting across the junction. It is the minimum amount of voltage that you need to provide so that these electrons can cross over to the other side. So different materials have different junction voltages. Okay, silicon diodes usually 0.6, sedikit saja voltage, and then they can cross over. Okay, why they cannot cross over is because of this depletion layer lah. And why the depletion layer is because of, okay, saya banyak kali sudah ulang. Okay, so the conditions for the electric current to flow is if it is connected to a dry cell, the voltage applied must exceed the junction voltage. That's a very important thing. If you sambung this semiconductor diode to a battery that is only 0.05 volts, okay, it's not going to be able to, there's no current flow. Although there's a voltage, there will be no current flow because you cannot overcome the junction voltage. Okay, so that's why okay, we need a minimum amount of voltage in order for the junction voltage to be overcome. Okay, so the effect of this junction voltage is to prevent the charge carriers from drifting across the junction. At this point, I'm just repeating a lot of things already lah. Okay, the junction voltages for germanium and silicon are 0.1 and 0.6. Now, in order for electric current to flow, the voltage applied must exceed the junction voltage. And that's why forward bias becomes very important for us. Okay, when it is forward bias, current can flow, resistance is low. When it is reverse bias, the current cannot flow, and so the resistance is high. Now we come to the part where we finally talk about the thing that is in your module. Okay, have your modules ready? I think this is it, right? Yeah. Oh dear. Do you know that I also like this chapter, but I just don't like the explanation part. Okay, forward bias circuit. Okay, forward bias circuit. Forward bias circuit, as we said, the positive terminal is connected to the anode. Okay, the anode is always the p-type conductor. So what happens is this. Okay, the connection p-type and n-type semiconductor to the battery terminal is p-type is connected to the positive terminal and the n-type is connected to the negative terminal. Forward bias lah. Okay, the positive terminal of the battery is connected to the anode. Okay, stay with me, people. 20 more minutes. Okay, and I promise you we'll be done. Okay, positive of battery connected to p-type semiconductor. Okay, negative of battery is connected to n-type semiconductor, which is the cathode lah. Okay, so I'm giving the same thing as I explained just now. Now, what happens to the movement of electrons and holes? Disebabkan sini adalah positive, the electrons here will be attracted to this side very naturally, and they will be attracted to this side. So the electrons will be able to move across the junction to the positive terminal, and the holes move across into the opposite direction to the negative terminal. Okay, I know I'm saying this word move over here because in reality, it is the electrons that are moving and they're just leaving the holes behind. okay, in the opposite direction to the negative terminal. And so because of that, sorry, the battery voltage to the junction voltage, the battery voltage is larger than the junction voltage, definitely. Okay, and so because of that, the depletion layer will become much thinner. Okay, kalau kita tidak membekalkan voltan, the depletion layer is always going to be there. But when we supply the diode with voltage and we put it in forward bias, we are giving these electrons enough energy to cross over the junction voltage and to allow current to flow. Okay, because remember, current can only flow if the electrons are moving in the opposite direction. Okay, and so the junction voltage has become smaller, and that's why the depletion layer becomes thinner. Okay, and so the resistance of the diode becomes small. Then that's why current can flow. Okay, current can flow? Yes, current can flow. This is because the charge carriers can move across the junction. Why can they move across the junction? Because the battery voltage is bigger than the junction voltage. The depletion layer is narrow and the resistance of the diode is low. Okay, so this is all the things that are happening in the forward bias, which I spent a very long time trying to explain apa ba itu junction voltage, apakah itu depletion layer. Okay, if it's just this kan, okay, I sorry lah, I don't know lah, but if I were just to talk about this, okay, I will akan ada banyak soalan lah, like apa itu junction voltage, apa itu depletion layer, tiba-tiba disebut dalam modul bah. Even in your textbook, okay, I read your textbook and I'm like, there's no introduction to the depletion layer, there's no introduction to the junction voltage, terus kamu faham begitu saja. So I'm like, okay, sorry guys, I have to make this long explanation about junction voltage, depletion layer semua. Okay, and if you don't understand this, wait until the video comes out, watch it again. Okay, hopefully after you watch like maybe 5 times, okay, or you think about it slowly, okay, it's actually quite easy to understand one. Okay, it's just mungkin saya menjela-jela cakap bahkan itulah yang menjadikannya sangat okay, reverse bias. Reverse bias is exactly the same thing, but in the other direction. Okay, so reverse bias, the connection is now different. The positive terminal is now connected to the N-type semiconductor. Okay, let's think about this. If the positive terminal is connected to the N-type, the electrons are always going to move towards the positive terminal. Just like forward bias. Electrons akan sentiasa bergerak, like forward bias, the electrons will move towards the positive terminal. Okay, oh dear, sorry, hold on. Okay, the electrons over here, dia sentiasa akan bergerak ke arah the positive plate. Okay, and since it is crossing over the depletion layer, it's going to make the depletion layer smaller. Okay, but in reverse bias, because the positive terminal is here, electrons are going to move over here. And so what's going to happen is the depletion layer is just going to get wider and wider and wider and wider, because all the electrons are moving away from the depletion layer. Okay, so the movement of the electrons and holes, the electrons and holes are pulled away from the junction. Okay, the electrons are going here. So there are no charge carriers that are crossing this area. Nobody is crossing, the pemisah lah. Okay, so what happens is the battery voltage will become smaller than the junction voltage, because the bigger the depletion layer, the bigger the junction voltage. Okay, remember when I showed you the original, this one just now, let me see, this one, okay, 0.6 volts and 0.1 volts, we're talking about only one layer, one layer of depletion voltage, depletion layer. But if the depletion layer becomes bigger, the junction voltage also will become bigger. Okay, and how do we make the depletion layer become bigger? We set it up as reverse bias. Okay, so that the junction voltage will be larger. Okay, so the thickness of the depletion layer will be thick, and this causes a high resistance. Okay, and because there's high resistance, there will be no current flow. Okay, so this is because no charge carriers across the junction, the depletion layer is wide, and the resistance of the diode increases. Okay, so if anything lah, okay, after me talking for 1 hour, okay, giving this super long and boring lecture, which you wish that you didn't have to hear it at 3:30 in the afternoon. Okay, never mind. Okay, if anything, okay, this is a very important thing. Forward bias, current flow, and why. Okay, reverse bias, no current flow, and why. Okay, if you don't understand anything that I've been saying for the past 1 hour, okay, at least this lah, sekurang-kurangnya ini. You must be able to explain why there is current flow in forward bias and why there is no current flow in reverse bias. Okay, if you don't understand anything that I've been saying for the past hour, okay, at least make sure that you know this lah. Walaupun kau tidak faham, pastikan kamu tahu. Okay, forward bias is because the charge carriers are crossing the junction, making the depletion layer thinner and the resistance decrease. Reverse bias is the other way around. Okay, the charge carriers are not crossing the junction, it becomes wider, the depletion layer, and the resistance increases. That's why there is no current flow. Okay, so the pool of electrons to the right, okay, in this case, this is reverse bias, right? Because n-type is connected to positive. So the pool of the electrons will cause the width of the depletion layer to increase. Seolah-olah dia kena tarik macam ni. Okay, so that's why the resistance increases, no current flows, the light bulb does not light up. Okay, in the forward bias, the electrons are pulled this way, the holes are pulled, the holes are pulled this way. So the depletion layer will become much thinner. Okay, so for today, I want to leave this with you here because this next part, if you don't understand what's happening in this first part, this next part, the function of the semiconductor diode and capacitor as a rectifier, not so much of a problem now. But today, you need to understand the meaning of reverse bias and forward bias and what is the explanation behind these two. Okay, why is it that current can flow in forward bias and cannot flow in reverse bias? Okay, from the activity that we saw just now, this one. Okay, when it is forward bias, when it is forward bias, okay, the bulb lights up. Okay, other current flow. So the behind part is why is there current flow? So what if it is forward bias? Okay, why is there current flow? And then if it is reverse bias, there is no current flow. Why? Okay, at least those very few things I would like you to know this lah. Okay, if you don't understand the explanation, if you like, I have no idea what Sir Marcus was talking about for the past 1 hour. Saya dengar saja, tetapi sebenarnya saya langsung tidak memahami. Okay, I understand. Even for me, when I first learned this, it took me a while to like, what on earth is my teacher talking about? Okay, I understand. I understand because it is so macam tiba-tiba ada element chemistry lah. Okay, in this physics part. Okay, but I would advise you that if you understand what the forward and the reverse bias means, watch this video again and understand about how the depletion layer is formed and why is there a junction voltage. Okay, and when it is forward bias, the voltage that you supply is bigger than the junction voltage because the junction voltage gets smaller and smaller and smaller. Reverse bias, the voltage that you supply is smaller than the junction voltage because the junction voltage gets bigger and bigger and bigger. Okay, there is a connection over there. All right, so that's it for today. That's it for this week lah. Okay, just to remind you, please finish the tutorial 1 and send it as one PDF. Okay, this is slightly different because there's so many pages. I don't expect you to send so many pictures into the Telegram channel. So send it as one PDF, but send it into the channel as well. Okay, and wait for this video to come out. And I'll post this again lah. Okay, and maybe over the weekend you might want to consider watching it to see whether you can understand it better. Okay, sometimes when we watch something for the second time, we understand it better.